Hello everyone and welcome to our channel. Today I would like to review very important topic, which is troubleshooting OSPF version 2 neighbor adjacencies. Let's get started. As you know, for OSPF routers to establish neighbor relationships, they need to exchange OSPF hello packets on the interfaces where OSPF is enabled. There are two ways to enable OSPF on the interface, on the router interfaces. First one is under the OSPF configuration mode. You need to enter command network IP address wildcard mask area and area ID. Once you enter this command, interfaces which has IP in the range in this subnet, in the range of this subnet, they will enable or run OSPF process on these interfaces. And the second one, directly in the interfaces configuration mode, you need to enter command IP OSPF process ID area with area ID. Considering this, that you have two ways to enable OSPF on the interface on the router, you need to be very careful while troubleshooting OSPF adjacency. To verify if routers have formed OSPF neighbor relationship, you can enter command show IP OSPF neighbors, and then you will see this kind of output where under a neighbor ID you can see router ID of the neighbor and the priority of the neighbor router state, the state of the neighboring router, which can be DR, BDR or DRODER, that time which shows how long router is waiting for the hello packet on this interface to declare the neighbor is down, IP address on the interface of the neighbor, and the local router interface. Once OSPF neighbor adjacency is formed, you will see syslog message in the console, which show that process ID, neighbor on which interface, and state became full and loading is done. Okay, let's check this example. I don't have OSPF process running on router R1. I'm supposed to have area 0 on this router, on this link, and these links are in area 1. So let's see, show run section router OSPF, nothing. So let's configure conf t router OSPF 100 router ID 1111. First, I would like to enable network. I would like to enable OSPF on the interface in the area 0 using first method network 10.12.0.0 area 0. As you can see, we received a syslog message that OSPF neighbor relationship is formed, and interface G01 IP OSPF 100 area 1. We should receive the same syslog message for this neighbor relationship to be formed. And let's check show IP OSPF neighbor. You can see that we have two neighbors, priority is default, and on these links each one is designated router. So router R2 and R4 designated, timers, address, and interfaces. There are several reasons why neighbor adjacency for OSPF failing to form. First one is interfaces down. You need to be sure that interfaces on the both ends of the link are in up state. Next reason is interfaces not running the OSPF process. You need to be sure that OSPF process is enabled on this specific interface for this neighboring link, and this can be done under the interface configuration mode or under the router OSPF configuration mode, so be sure that this is correct. Next one, mismatched timers. Hello and dead timers must match on the both ends of the link, otherwise OSPF will not form neighbor adjacency. Next one is mismatched area numbers. So both ends of the link, both these interfaces must have the same area number configured for the OSPF. Mismatched area types. So routers need to agree on the area type. They can be in normal OSPF type area, they can be in not so stubby area or in stub area, but they need to agree on the same area. Next one is different subnets. So there should be configured the same subnet on each ends of the link between routers. Passive interface. This is good feature, especially for security purposes. But if you configure passive interface on incorrect interface, which need to form adjacency, adjacency will not form because passive interface is not sending hello packets. Next one, mismatched authentication information. If you use authentication for OSPF, be sure that authentication information is identical on both ends of the link between routers. ACL, this one you need to be sure that OSPF multicast packets to address 224.0.0.5 are not denied by ACLs. Next one, MTU mismatch. Be sure that both ends of the link on the interfaces are configured with the same MTU, or MTUs are matched on these interfaces. Next one, duplicate router IDs. Here you need to be sure that router ID is unique for this router within OSPF domain. Last one, mismatched network types. Based on OSPF network type characteristic and default values, there might be issues in forming adjacency between two neighbors configured with different OSPF network types. For example, broadcast network type and point-to-point network type. There might be issues to form OSPF neighbor adjacency. Neighboring routers will not form a neighbor adjacency right away after receiving hello packet. They need to go through some states. Let's review these states. There are 8 states. First one is down. It means that there is no packets have been received from the neighbor. Second state is attempt. When router sends a unicast hello to configured neighbor but hasn't received a hello from the neighbor. Next one is init. When the router has received a hello message from the neighbor, but there is no the OSPF router ID of the receiving router in the message. If router stays in this state for a long time, that might mean that something is preventing the router from correctly receiving hello packet. Two-way. When routers have received hello packets from each other and have found their own router ID in those hello messages, this state is unacceptable to stay in between two browsers on the Ethernet LAN. X state. At this state, routers which are forming adjacency decide who will send the routing information first. During this state, the router with the higher router ID becomes the master and sends its routing information first, and the other router becomes the slave. In a multi-access network, the DR-BDR election has to be completed before this state, and DR is not obligated to become master, as master-slave election happens per neighbor basis. So only on the link master-slave election happens, and there is nothing to do with DR election. In case a router stays in this state for a long time, there are two possible reasons. First one, MTU mismatch could exist between the neighbors. And the second one, duplicate OSPF router ID might exist. Next state is exchange state. In this state, two routers which are forming adjacencies send each other database descriptor packets, which contain information about the router's link state database. When the router receives the DBD packet, it compares it with its own database to identify missing entries. If router stays in this state for a long time, it might mean that MTU is mismatched between two routers. Next state is loading. If there are missing entries in the link state database identified in the exchange state in the previous state, routers request the other routers for those missing entries during this state, which is loading state. If the router stays in this state for a long time, then it might mean that a packet might have been corrupted or a router might have a memory issue. Or it is also possible that neighboring routers have an MTU mismatch. And the last state is full. This state is indication that neighboring routers have finished successfully exchanging their link state information with one another and neighbor adjacency has been successfully formed. If an OSPF neighbor adjacency does not form, there is no neighbor in the neighbor table. So if there is no neighbor adjacency, when you do show IP OSPF neighbor, you will not see neighbor in this table. For that reason, to troubleshoot issues, it is good to have an accurate logical and physical network diagram and then use command show CDP neighbors for verification. Now let's review each mentioned previously reason for OSPF neighbor adjacency failing to form. First one is interfaces down. To check if the interface is in up state, you can use command show IP interface brief, and you need to do it on both ends of the link on interfaces of both neighboring routers. In the output, you can see that status of interface is up and protocol is up. This is good condition. So let's check the situation in example. We have same network, we have area 0, we have area 1, area 1, area 1. So let's see what we have on this router. Show IP OSPF neighbors. We can see that we have only router R4 in our neighboring. This router formed a neighbor adjacency only with router R4, but we have also router R2. Let's see what we have with interfaces. Show IP interface brief. As you can see that interface is up state. Let's go to another one. Show IP interface brief. And you can see that this interface is in state administratively down. Conf T interface, let's bring it up. 0, no shut. Let's wait. And interface is up. Now they need to form, yes, they formed OSPF neighbor adjacency with this router with router R1. That was issue with interface is not in up state. Next issue is interface is not running the OSPF process. As you know, to enable OSPF process on the specific interface, you can use one of two commands. First one is network IP address wildcard mask area ID in the OSPF process configuration mode. And the second one is IP OSPF process ID area ID in the interface configuration mode. The problem appears if those two commands are misconfigured, or if you use only one command, it might be misconfigured and OSPF enabled on the wrong interface. Because of such misconfiguration, hello packets are not sent and neighbor adjacencies are not formed on correct interfaces. The other issue might be if you misconfigure area ID in the command, but this is different issue and we will talk about it later. To verify which interfaces are participating in the OSPF process, use the following command: show IP OSPF interface brief. Here you can find interface on which OSPF process running, process ID, area, IP address, cost, and state of this router on this link. Another useful command to verify interfaces where OSPF is enabled and areas is show IP protocols. If both commands, network IP address, wildcard mask, area ID, and IP OSPF process ID, area ID are used to enable OSPF, then the last one takes precedence. So this one takes precedence over this command. So let's review this quick example. We have same network. We have area 0, area 1, area 1, area 1. And let's see, as you can see already, we're receiving syslog messages in the console that mismatched area ID. Show IP OSPF interface brief. As you can see, we have in OSPF enabled only on interface G00, but area 10. This should be area 0. Let's see, show run, section router OSPF 100. As you can see, there is no for area 1, maybe on the interface. Show run interface G00. Show run interface G00. As you can see, it is enabled under the interface configuration mode. Let's fix it. Conf t interface G00. No IP OSPF 100 area 10, and let's do it IP OSPF 100 area 0. Let's see what's gonna happen. Okay, from loading to full, show IP OSPF interface brief. So now we can see that area is correct and we are not receiving this syslog error message. And let's review what's the wrong with this neighbor adjacency. Show IP OSPF neighbor. We're not gonna see this. Let's review command show IP protocols. And as you can see, routing enabled for networks, area 1 is correct, but network is not correct. On this link between R1 and R4, we have network 10.14.00 mask 24. So we need to correct this. Router OSPF 100. No network 10.144.00 Wi-Fi area 1 and enter correct network and correct command with correct network area 1. And let's see now we can see that already neighbor adjacency has been formed. Show IP OSPF interface brief, and we can see it's correct. Show IP OSPF neighbors. So we have neighbor adjacency with both routers, and one more time this command. And you can see that for this interface area correct, IP address correct, and everything is correct. So next issue which might happen is mismatched timers. In order for neighbors to form adjacency, timers must match on the interfaces connecting neighbors. By default, hello timer is 10 seconds for broadcast and point-to-point network types and 30 seconds for non-broadcast and point-to-multipoint network types. And that timer is defaults to 4 times hello timer. For example, 40 seconds for broadcast and point-to-point network types and 120 seconds for non-broadcasted point to multi-point network types. To verify current timers on SPF, use the following command: show IP OSPF interface and then interface type, interface number. In the output you will find such string, time intervals configured, hello timer and dead timer. For troubleshooting adjacency and revealing mismatched timers, use the following command: debug IP OSPF hello. This will run debugging for hello packets, and then you will see that timers are mismatched. Let's review this issue in example, the same network, area 0, area 1, area 1, area 1. Let's see what we have on router R1, show IP OSPF neighbors. As you can see, we have neighbor relationship only with one router R2, and we have R4 missing. Show IP OS protocols. Routing enabled for networks 1014, which is good, and area 1, and on interface G00. Show IP OSPF interfaces. Brief. You can see we have OSPF enabled on for both interfaces, and correct areas, correct IP addresses. Show IP OSPF interfaces G00. Let's see timers 1040. Okay, and second one 10 and dead interval 9. Let's see what we have on router R4. And show IP OSPF interfaces G01. And R4 has dead interval 40 configured on interface. This is the issue. Let's see. Let's do debug to just see what is gonna show. Debug IP OSPF hello. Let's wait. Okay, we can see that send hello for area 0, hello from debug all. We can see that receive hello from 4, mismatched hello parameter from 10.14.04, dead interval 40 received, and configured 9. So we, as it was mentioned in the slide, we can check also this issue with this debug command. Now we just need to go and change this dead interval conf t interface G01 IP OSPF dead interval 40. And let's see what we're gonna have now. We should form, yes, now neighbor adjacency formed. Show IP OSPF neighbors, and now we can see both our routers in the with formed adjacencies. So this is the issue with mismatched timers. Next issue is mismatched area numbers. For OSPF routers to form the neighbor adjacency, their neighboring interfaces must be in the same area number. So area must match on those interfaces on the link. To verify the area on the OSPF interface, use the following command: show IP OSPF interface and then interface name and interface number. In the output you will find area of OSPF area on this interface. Next useful command is show IP OSPF interface brief, which also shows area for this interface. And you also can find mismatched area numbers when troubleshooting adjacency with the debugging command debug IP OSPF adjacency. In the output, you will find such a packet which shows that area is mismatched in the header, in the OSPF header. So let's review example. For this issue, we have some network, area 0, area 1, area 1, area 1. Let's see what we have on router R1. Show IP OSPF neighbors. We can see that we have only one router, that router R1 has formed neighbor relationship. Let's see show IP OSPF interface brief. As you can see, this is our interface facing router R4. IP address is correct, and we have problem with area number 11, but it's supposed to be 1. Show IP OSPF interface G01, and you can find this also in this command, interface internet address and then area 11. Let's see what we can see from debug. Debug IP OSPF adjacency. Let's see. Okay, now we received the syslog message showing that received packet from 1404, which is router R4, area 11 mismatched with area 1 in the header. So as we can see also from the debug, we have mismatching area and debug all. Let's fix this situation. Conf t router OSPF 100 network 10 14.0.0.0.0.255 area 1 to show run section router OSPF 100 router. Okay, now is correct. Show IP OSPF neighbors. We have neighbor adjacency with router R4, and now everything is fine. Show IP OSPF interface brief. We have correct area and everything is good. This is everything I wanted to show you for today. Thank you very much for your attention.
Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.